Here's my Heathkit 3600 analog trainer from 1992. I'll set all the controls to 0, then adjust the positive DC output to 5 volts. This is the Engineer's Mini Notebook, Digital Logic Circuits by Forrest M. Mims from 1986. Let's build the transistor NAND gate from page 6. Here's my version of the schematic using an LED for the output. You can get it for free on my Patreon. Let's start with just the LED. First, run ground and power to the solderless breadboard. The long leg is the anode and goes to the top side of the trench. Connect it to 5 volts with a 330 ohm orange-brown resistor. This keeps the LED from getting too much current from the 5 volt rail. We say this resistor pulls the LED up to 5 volts, so we call it a pull-up resistor. The other leg is the cathode. Connect it to ground. Our input wire goes here between the resistor and the LED. With the input disconnected, we can turn the power on and the LED lights. To turn it off, we connect the input to ground. From the point of view of the resistor, electricity has a choice of one of 2 paths: to ground directly or to ground through the LED. Electricity always chooses the path of least resistance, so it takes the path directly to ground. No current flows through the LED. To light the LED again, we disconnect the input from ground. Can we connect the input to 5 volts? No. Connecting 5 volts to the input would send current directly through the LED, with no resistor to limit the current. In this circuit, we light the LED by disconnecting the input, and we turn it off by grounding the input. We never connect the LED input to 5 volts. Let's build the next step, the inverter. Power off to change the circuit. Replace the input wire with a jumper to a new breadboard location. Now we add a 2N2222 transistor. Its right side lead, known as the collector, connects to the input jumper. The transistor's middle lead, known as the base, controls whether it is on or off. Like the LED, this lead can't take much current at all, so we add a 10 kiloohm brown, black, orange resistor. We're using the transistor as a switch to ground the LED's input, so we connect the left lead of the LED, known as the emitter, to ground. Now when the transistor is on, it will ground the LED's input, and when it's off, the LED's input will be disconnected from the circuit. Let's connect the transistor's input to ground. Power on and the LED lights because the transistor is off and the LED's default state is to be on unless it's grounded. Move the transistor's input to 5 volts, the transistor turns on, and the LED's input is connected to ground. The LED turns off. Looking at the truth table, the state of the LED is opposite the state of the transistor's input. In other words, the output, the LED, is the inverted version of the input.